Clearly we're talking about the second derivative here, but you know what? We can do a third derivative, a fourth derivative. We can just keep differentiating as much as we want. We just got to know why we're doing it and what the answer means. So let's just first work out that the slope of a function is rise over run. So we've got things changing. It's the change in y over the change in x. So things are changing, and how quickly are they changing is this slope. Let's think about what we've been doing in grade 8 and 9 and 10. If we've got a distance time graph, then that car is travelling faster than that car because it's covering more distance over a shorter amount of time. The slope is greater on this black one than the green one. This fella is slow because the gradient is slow. The next thing we would have done is gone, the slope is the same all the way along, so his velocity, his speed is constant. He's just travelling along the highway. This guy is at a set of lights. He's actually stationary there. He starts off slow and is getting faster and faster, so his velocity is actually, his displacement is changing, so he's getting faster and faster, which means his rate of change of distance, so the slope here and the slope there is different. That means he's accelerating, his velocity is changing. There we go. So we're getting the slope of different things, so we want to work out why we're going to differentiate more than once. Okay, if the velocity is changing, what is happening? So if that we had a displacement time graph, but what if we had a velocity time graph, and something was changing? If my velocity is changing, so the gradient of a velocity time graph gives acceleration. How do I find the gradient of a velocity time graph? Well, I need the gradient function. I'm going to need to differentiate that thing. So let's just do one here where the distance is a cubic. So it's sort of irrelevant. It's going to look something like that, but who really cares? So if I've got a displacement time graph, if I do a first derivative, which is 3t squared minus 2t, that function isn't just d/t, it's not just the gradient of the distance time graph. We would call that a velocity graph. This function is going to give me the velocity of that object for any time t. Hey, let's do a second derivative. I don't know why I put t in there twice. We're going to differentiate that bad boy again. 6t minus 2. Well, that's the second derivative of my displacement time graph, but it's the first derivative of my velocity time graph. And we know that that's acceleration. So this is actually my acceleration function. So what is my acceleration after 2 seconds? 10 meters per second per second. So you can see I've differentiated once, I've differentiated twice, I can differentiate again if I wanted to find the change in my acceleration. Is it a constant acceleration? Is it a changing acceleration, etc., etc.? Anyway, you'll see as the questions come, there's more than one reason to do a second or third derivative. Some are abstract, and we will come across more as we move forward in the curriculum.